guys, hope you are doing well. I'm Kumar K, your favorite DSA teacher. When it comes to solving hard unseen DSA problem, which requires lots of complex logic and intuition, okay, hard unseen DSA problems of online assessments, online tests of top tech companies, and competitive programming and coding contest problems. Today, I'm very happy. Think why I'm happy. I'm always happy when my students get selected. So, guys, if I go to the document, this document link will be there in the description of the video. Okay, many of you keep on asking me where is the material is in the description of the video. So guys, the first thing, congratulations to my student for cracking a great offer, very high paying offer off campus from Amazon. Okay, despite not being from a top tier college, she cracked it off campus. My student did it. Congratulations to Sukriti. She has been training very hard with us for DSA, OA, CP, one-to-one mentoring, referrals, everything combined. After 8 to 10 months of hard work, Sukriti has generated the offer. She was a beginner few months back, but now she is awesome at DSA, OA, CP, and she has offer from Amazon off campus. Similar to her, guys, 2 days back this happened, and then 5 days back another student of mine cracked off campus offer from Amazon. Like, there have been so many selections in so many companies, but in today's video I'm thinking of mentioning the Amazon one because it reminds me of my days when I got the Amazon offer a few years back. I was very happy. So Harini, congratulations for cracking off campus offer. She has worked hard since 10-15 months. I know her. I know her struggle. Then, guys, congratulations to Abhirami as well. She has also cracked a very great offer from Amazon. So, congratulations to her. Great job. Great job. So, like this, on a daily basis, we have many selections. Okay. Now, coming to my introduction, I have previously worked at Amazon and Mia.net as a software engineer. And coming to our love for DSA, I have All India Rank 12 in Google Code Jam 2021 and All India Rank 4 in the recent Facebook Hacker Cup. So, guys, if you want the best level DSA plus OA plus EB training in the country, you can join our one-to-one mentoring and personalized training program, where all the live classes are by me, and you get the one-to-one mentoring with me as well. Also, you'll get full stack development feature, system design training feature. You will get referrals of top 500 companies. Many things are there, and we have selections on a daily basis. So if you are interested, you can check the link in the description. We have special offer of New Year on the new batch which has been getting launched. Now, guys, today we are going to solve very interesting problem. Everything is making me so happy today. The problem is Rubrik OA, guys. Rubrik OA offers anywhere from CTC 60 lakh to 80 lakh, okay, for their SD role and fresher SD role. So we will try to see what kind of questions is Rubrik asking for DSA in their OA rounds, online test rounds, okay? And we will see that how to tackle these type of questions. Generally, the problem is that students only prepare standard DSA problems, 100, 200 problems from the standard popular DSA sheets, and that is never enough to tackle the hard unseen DSS questions of the online assessment, because they always make up some story and ask you a total new question which you have never seen before. So you need lots of critical thinking skills. You need to practice critical thinking skills and complex logics, and that's what we do in our program. So now let's go to the question and let's start enjoying the problem. So problem is this: Rubrik is a global leader in cloud data management, providing cutting edge solutions for data backup, disaster recovery, and cloud storage. If I come below, you have to create a binary string, okay, of zeros and ones such that f of s value is maximized. You have to generate a string of length n which has m number of ones in it, and f of s should be maximized, okay? So, guys, I hope the basic explanation of the program is clear to all of you. The basic explanation is that you just create a binary string of length n. In that, there should be some zeros and ones. The number of ones should be exactly m, and f of s is some function we don't know. We have to maximize the value of f of s. So, guys, let's say I tell you that n is equal to 5 and m is equal to 2. Can you create a binary string? Binary string means string should have only zeros and 1. So of size 5, yes, 1, 2, 3, 4, 5. They are saying that there should be two ones also. M means the quantity of ones which you want in the string. So you can replace this 0 by 1 and let's say this 0 by 1. So this is a valid string. Why? Because this binary string has a total length of n and it has two ones. One, okay, First occurrence of 1 is here, second occurrence of 1 is here. There are many other strings also, they are also valid. This is also valid. Why? Because its length is also 5, and here also there are two ones. The position of the ones we don't know where to put, we can put anywhere. So there are many valid strings possible. So guys, I hope you got the gist of the problem. Is that you have to generate a binary string of length n, and it should have m number of ones. If m is 1, there should be one occurrence of 1. If m is 2, in your binary string, not substring string, there should be two occurrences of 1. If m is 3, somehow you have to put three occurrences of 1 in the binary string of length n. And m is always less than equal to n, because if string size is n, how can you put more than n ones, right? So that's it. Now what is the f of s function? That's what we are going to notice now. So if I try to make the understanding of the problem clear, construct a binary string of size n which has m number of ones, where m is less than equal to n, and rest numbers will be 0. I hope that commonsensical thing is clear to you people. I'm loving this problem, because in the future there will be many interesting concepts and logics getting discussed, and I'm so happy thinking that how it will make my audience and students go stronger in their DSA journey. I want you to, I want to make sure that you fall in love with DSA. You should not do it forcefully, you should love the beauty of it. So this thing is clear. What is f of s, guys? F of s is nothing but count of binary strings which have at least one occurrence of 1. So f of s, let's say I make this string. The length n is 3 and m is 1, means a single occurrence of 1 I have put here. Okay. So what is the value of f of s here? F of s means all the substrings which contain 1. How many times 1 is coming in that substring, that does not matter. So guys, which are the valid substrings? From 100, 1 is a valid substring because it has 1 in it. Then 10 is also a valid substring, and then 100 is also a valid substring. So for 100, f of s value is 3. So guys, I hope you understood that the meaning of f of s is nothing but the number of substrings in your created string which have at least one occurrence of 1. So in 100, which are the substrings which have only one occurrence of 1? Think about them. It is 1, then 10, 100. All these three substrings of 100 are valid. They are contributing themselves to f of s. So f of s is 3. So I hope it's clear. The meaning of f of s is count of binary substrings. Count of binary substring which have at least one occurrence of 1. Okay, is maximized. Okay, so later on we will maximize, but f of s meaning is that only. So guys, currently the meaning of f of s is very difficult, right? They are saying that generate a binary string such that f of s is maximized, but no thoughts are coming to the brain. मैं कैसे एक बाइनरी स्ट्रिंग बना दूं लेंथ n की जिसके अंदर m नंबर ऑफ वंस हो बट f of s मैक्सिमाइज हो जाए? मुझे पता ही नहीं f of s वर्क कैसे करता है. So how will I achieve that? Okay, so how will you create a binary string of size n which has m number of ones in it such that f of s is maximized? If you solve it, you will get the offer from Rubrik if after passing the interview of 60 to 80 lakhs. So what to do? High stakes, right? So now what we can do is enjoyment. Guys, if I tell you n is 3, m is 1, give me a valid substring of this such that f of s is maximized. So you can say, sir, s equal to 100. In this case, 1 is a valid substring. So I create a string 100. Why this is valid? Because size of the string is 3 and there is exactly one occurrence of 1. So what will be f of s for this? There are three substring of this which have at least one occurrence of 1. This one, this one, this one. So f of s is 3. So guys, is this the best possible answer? Is 100 the best string of size 3 which has exactly one occurrence of 1? No, there is a better string possible. And that better string is our answer. So that better string is 010. Why is this better? First of all, it is following all the rules. Size is 3 and exactly one occurrence of 1. But this time 1 is in the middle. So guys, which are the substrings which will contribute to f of s? Zero 1 is a valid substring, right? Then this 1 0 is also a valid substring, right? Then only one if you take, that is also valid substring, right? So many valid substrings are there. Then 0 1 0 is also valid substrings. Why are they valid, guys? Guys, there are four valid substrings. So this time f of s is coming as 4. Earlier f of s was 3. So our f of s has become bigger, maximized. So 0 1 0 is the correct answer. F of s equal to 4 is the correct answer. Why is f of s equal to 4 for 0 1 0? Because in 0 1 0 there are four substrings which contribute to f of s. How they contribute to f of s? Because those substrings have at least one occurrence of 1. So f of s, there are four substrings: 0 1 1 0 1 and 0 1 0. All these substrings have at least one occurrence of 1 and hence f of s is 4. Now guys, I hope you understood the problem. So how can we make it easy? So if I give you any binary string, okay, let's say its length is n and it has m number of ones. So f of s, we will write a formula for f of s, okay? In this case, we will just write a very lovely the Google Meet, the Google Meet getting naughty sometimes. Anyways, focusing back to the question, Ram Ram. So guys, f of s can be written in a beautiful formula way. I want to show it to you, okay? The formal way of writing f of s, which makes the problem very, very easier. Okay, this is my LinkedIn. You guys already know about that, right? So how can we make f of s easy? Okay, how can we make f of s easy? F of s is nothing but, see guys, if I give you a string of length, then how many total substrings will be there? N into n plus 1 by 2. This much mathematics you should know. Obviously, Rubrik OA of 60 to 80 lakh problem is only for the non-beginners of DSA. This video should only be watched by non-beginners. Here I assume that you know all the basic concepts of DSA already. Okay. But guys, if I give you a string of length, then how many substrings will be there? N into n plus 1 by 2, right? Out of them, some substrings will be the one which have at least one occurrence of 1, right? And then there will be substrings which have zero occurrence of 1. I mean to say that you create any binary string in this world which has some zeros and ones. How many substrings will it have? It will have n into n plus 1 by 2 substrings. I hope you know what is the meaning of that. For example, let's say I create this. This is my string. The number of substrings is as n into n plus 1 by 2. Why? What is n? Length is 3. So there are 3 into 4 by 2. There are 6 substrings. Which are the 6 substrings? One substring is this. Second number substring is this. Substring is nothing but smaller part of the original string. Third substring is this. Fourth substring is this. Fifth is this. Sixth is this. Okay. So there will be, I make any kind of string, there will be n into n plus 1 by 2 strings. Out of these, there will be further two divisions. Some of those strings will have at least one occurrence of 1 and someone will have no occurrence of 1. So guys, here we know that there will be 6 strings. Guys, which are the strings which have at least one occurrence of 1? 0 1 1 0 1 and 0 1 0. Guys, which are the strings which have no 1? Now guys, we enter an interesting territory. Which are the strings which have zero occurrence of 1? Means 1 is not coming in them. It means that those substrings should have only 0 in them, nothing else. So this is one substring which has no 1 in it. 1 0 here. And this 0 is also a valid substring because it has no 1 in it. Okay. So guys, this is 4, this is 2. So 4 plus 2, 6. So here also at least one occurrence of 1. Whichever are those substrings, we call them as f of s. And whichever strings which have only 0, we call it as g. So I can say that, I can easily say that total number of substrings is nothing but number of substrings which have at least one occurrence of 1 plus The number of substrings which have only 0 in them. Basically, zero occurrence of 1. The substrings which have only 0 in them. So what is f of s? F of s is nothing but total minus g. Total is what? Total is n into n plus 1 by 2 minus g. G is nothing but what? Number of substrings which have only 0 in them. See, the question has become so interesting now. So you have to maximize total minus g. Total minus g you have to maximize. Now you forget about f of s. F of s is nothing but total number of substrings minus g. Total is a constant number, n into n plus 1 by 2. What is g? G is the number of substrings in a string which have only 0, which is easy to count. That's why we are doing this. I hope the intuition and complex logic is getting clear to you. So we have to maximize f of s. We have to maximize, which is nothing but total minus g. So we have to maximize total minus g. Total is constant, n is constant. So n into n plus 1 by 2 is constant. So you have to minimize g. If this g is small, then total minus g will become big. It means then f of s will become big. See how nicely the greedy algorithm, exchange argument lemma, whatever we are going to do in the future, it's getting interesting now. So how will you maximize total minus g? By minimizing g. So guys, the final question is minimize g. The final question is minimize g. What is g? The number of substrings which have only 0 in them. Minimize those substrings. Okay, let's do it for some example, right? Guys, now the question has become very easy. Create a create a string of length n. See, no matter how hard the question, we can always, boil it down to simple, components. Just make a string of size n, which is a binary string, which has m number of ones in it, but the number of substrings having only 0, that should be as minimum as possible. So how will you do that? So let's do it for an easy case. I have written it here also. F of s is total number of substrings minus count of binary strings which have only 0 in them. Total number of substrings is n into n minus 1 by 2. So if you want to minimize the count of binary strings which have only 0 in them, f of s will be maximized. So let's do the easy case. Let's say m is equal to 1, n equal to 7. So guys, n is equal to 7, m equal to 1. It means you have to create a binary string and the length of the binary string will be 7. You have to put a single one in them, okay? So guys, what will happen if I put 1 here? Rest all will be 0, right? So this part will generate one substring which is having only 0. And this part will generate 1, 2, 3, 4, 5. This part will generate 5 into 5 plus 1 by 2 substrings which are having only 0. So which are having only 0 in them. So 5 into 6 by 2. So this part will generate 15 substrings which have only 0. And this part will generate only one substring which has 0. So total 15 plus 1, 16 substrings. So guys, if you put a single one at the second position, 16 substrings are getting generated, which have, only 0 in them. Now let's see what will happen if I put 1 at the next place. So if I put 1 at the next place, guys, what is going to happen? Something even more interesting. Now this part will be the part which has only 0 in them. So there are how many substrings which have 0 in them? If there is a continuous string of size 2, apply the formula n into n plus 1 by 2. These many substrings here will be having only 0 in them, which is nothing but 3. You can see now, 1 this, 2 this, and third substring will be this combined. And here there will be 4 into 4 plus 1 by 2. So here 3, and this will be 4 into 5 by 2. So 10 plus 3, 13. So guys, when you put your 1 at first position, the answer was 16. When you put your 1 at the second position, the answer is 13. Now guys, what will happen if I put 1 in the middle? 0 0 0 1 here, 0 0 0. So this will be 3 into 3 plus 1 by 2. And this will give how many substrings which have only 0 in them? 3 into 3 plus 1 by 2. I hope you understand how this formula is coming. If there are 3 0 consecutively, how many substrings of them will give 0? All of them will give 0 only, na? So that's why for this part of size 3, having only 0, 3 into 3 plus 1 by 2. And here also 3 into 3 plus 1, 3 into 4 by 2, 6. And this will also be 6. So 6 substrings from here which have only 0 if you put a 1 in the middle. And 6 substrings from here which have only 0. 6 plus 6, 12. So if you put the 1 in middle position, the G value is coming as 12. So G is minimum. G is minimum when you put 1 in the middle. Okay. So guys, hopefully everyone got the intuition here that if you have to create a binary string which has only single one, of and the size of the string is n, where should you put that one so that the G value is minimized? You should always put that G, always put that one in the middle. Okay. So we can, mathematically formulate it. Okay, you can assume it like this, that when you wanted to create a string, na, you know that this string is of length 7. You know that at somewhere you will put a 1. This part will be 0 and this part will have all the zeros, right? So what can be the permutation and combination? The left hand side can have one occurrence of 0 and this right hand side can have 5 occurrence of 0, because the total string length is 7 and 1 is getting occupied, so leftover is 6 only, na. So 1 plus 5 is the possibility. Next possibility is that the left can have 2, right can have 4 zeros. Next possibility, the left part can have 3 and the left right part also 3. And then guys, similar possibilities again, 4 plus 2 and then 5 plus 1, which is nothing but congruent to this. 5 plus 1 is nothing but similar to 1 plus 5 and 4 plus 2 is nothing but same. So guys, in all these scenarios, you can see here very clearly that when you divide it in 1 comma 5 fashion, na, you get a big number as G. When you divide it in 2 comma 4, still the G is big. But when you divide it in 3 equal parts, when you put 1 in the middle, 3 gets generated, which is minimizing the G. Rest all are giving big values. 0 and 6 is the worst. If you put 1 at the start, what will happen? You put 1 here. This much part is 6. Total is 7. So all this will be 0, right? So all this will be 0, right? So it will give how many substrings? 21 substrings. So G is becoming bigger. If you want minimum G, you should put the 1 in the middle. So guys, we have solved the problem when you for m equal to 1, where you have to only place a single one in the binary string. Okay. So guys, what does this observation tells us? The observation tells us that if their m is greater than 1, let's say they are now telling you that place two ones in the binary string such that G is minimized. So what should you do? Place the two ones in such a way so that the even distribution is happening. The zeros are coming equal number of times everywhere, as much as possible. Okay, I hope you got the intuition, feeling and logic here. So basic is what? If I am giving you, let's say, n equal to 9, m equal to 1. Now you are smart, you know what to do. This length 4, you will fill all zeros in it. This length 4, you will fill all zeros in it. And here you will put a single one because m is equal to 1. What will be the G value? 4 into 4 plus 1 by 2 plus 4 into 4 plus 1 by 2, and this is the minimum G value. And what will be the maximum f value? It will be total n into n plus 1 by 2 minus minimum G value. Minimum G you can easily calculate. Okay. Now guys, why 4 comma 4 is only given minimum G? We will try to prove it later. Okay. See, if n is 9, one place will be given to 1. So what will be the remaining? Remaining places for 0 is nothing but 9 minus 1, right? 8. 8 can be divided in this way. 0 comma 8, The left part can get 1, so 1 comma 7. The left part can get 2, 2 comma 6. Then 3 comma uh yeah, so 3 comma 5, or 4 comma 4. And like this there are many ways, but which is the best way? 4 comma 4 is the best way. When you put one in the middle, both of them get divided in equal quantities. Okay, so hopefully guys you have solved this problem in your mind. You have solved this problem easily for m equal to 1. Now let's do it for m equal to 2. So guys, the for m equal to 2, see, you understand it that the claim is that you should always place 1 in the middle. For m equal to 2, what will you do? You should distribute 1 in evenly distributed manner to get the minimum g. So n equal to 8, m equal to 2. So guys, this time you have to solve it. Okay, so n is equal to 8, m is equal to 2. Basically you have to create a string of length 8 such that there are two ones in it. So where will you place the two ones? 1 1 I will place here, 1 1 I will place here. So this place will have all zeros in it, this place will have all zeros in it, and this place will have all zeros in it. As per the intuition and the logic, all the number of zeros should be equal to for them to get distributed in even manner. Because even when you are putting a single one, do you remember, here also the number of zero was 4 and here also it was 4. So both of them should always be equal as possible. When it is not equal, it gives a bad answer. When the distribution of 0 is not equal, for example on the left hand side it's 1, on the right hand side it's 5, it gives a very bad answer. The best answer only comes when the distribution of 0 is equal in all the parts. So guys, I hope you understand that the best answer only comes when the distribution of zeros is equal in all the parts. So how will you distribute equal number of zeros in those three parts? Let's go through that. So let's assume that y number of zeros are coming here, y number of zeros are coming here, and y number of zeros are coming up here. So how many y's are there? 3 y's. If there are 2 ones, there will be 3 boxes getting created, right? So 3y plus 3y is this much space, and 2 ones are there, right? So 3y plus m is nothing but equal to n, total length. So n minus m divided by 3 is y. So what is y here? N minus m, 8 minus 2, 6 by 3. So 8 minus 2 is what? 6 by 3. So 6 by 3 is what? 2. So basically y is equal to 2. Basically this, here you have to put two zeros. Here also you have to put two zeros. Here also you have to put two zeros. So guys, the problem is solved. What will you do? You have to create a binary string of length n which has m number of ones in it. So if there are m number of ones, how many boxes will it create for 0? There will be m plus 1 boxes. So the formula will be the number of boxes into y plus the number of ones equal to the total length of the string. Okay, I will now give you any example. You have to quickly solve it for me. Okay, let's say n was 9, m was 2. What would you do? You know that this is of length 9. You know that 1 1 you have to put here, 1 1 you have to put here. So how many boxes will be there? One box for 0, they all will be 0. Another box for 0, last box for 0. So there will be 3 boxes. So number of boxes is nothing but m plus 1. So m plus 1 box into, let's say this length will be y, this length will be y, this length will be y. So m plus 1 into y plus the number of ones. 1 1 here, 2. So 2 ones are there, plus m is nothing but n. So n minus m divided by m plus 1 is nothing but y. So what is n minus m? N minus m is 9 minus 2, 7, divided by m plus 1, 3. So guys, this is not a perfect division, but 3 ones are 3, 3 2s are 6, like 2 point something, right? So each box should be of length 2. So guys, let's make a string like that. Length 2, then a 1, length 2, then a 1, length 2. So what is the length of this string? 1, 2, 3, 4, 5, 6, 7, 8. Okay, one remainder is getting left, right? What is the remainder? What is 7 mod 3? So guys, 1 0. See, you have. So guys, You have created a legit string, okay, by this formula. Two zeros, one, two zeros, one, two zeros. But now one remainder is left. One more zero you have to put. So put it anywhere you want, right? That's the solution. So here the two zeros are coming. This will contribute to G, right? 2 into 2 plus 1. Here also two zeros coming. Here also two zeros coming. One is left. So you add one zero here. In this place, there will be three zeros coming. Got it? And the remainder will, see, remainder is what? 7 mod 3. So if you are doing something mod 3, the remainder will always be either 0 or 1 or 2. So the extra zeros maximum you have to put at two places only. Here there are how many boxes? Here there is three boxes. Whatever the extra zeros come, you will put it one by one. One here, one here, one here. Okay, it will never exceed three. Okay, it will never exceed two also. So guys, hopefully you have understood the question. Now let's take a final example. Okay, how will you solve this problem? You know you have to create a string of length 10. You have to put two ones here, one here, one here. So this length should be y, this length should be y, this length should be y. So what will be the answer? 3y, right? So 3y plus 2 is equal to 10. So 10 minus 2 divided by 3 is equal to y. So this is nothing but 10 minus 2, 8 by 3. 3 ones are 3, 2 is 6. Okay, so it is 2 point something. So basically it will be 0, 0. It will be 0, 0, 0, 0, 0, 0. So you got it that how many, zeros you have to put. But guys, there is some remainder getting left out. What is the remainder? Remainder is 8 mod 3. So two zeros are extra which you have not put in the scenario. So where will you put the two zeros? See, in the first bracket, two zeros are coming. Second bracket also two zero. Third bracket also two zeros. So where will you put the extra two zeros? Two is extra. So one zero you will put here for the even distribution, and this will become three. And one zero you will put here. This will become three. So the final distribution looks like 2, 3, 3. And here this is the best even distribution possible. Why? Because here each distribution has generally the same size. Maximum difference of 1 is possible. So guys, mathematically if you observe now, you will understand that the question given any n and m na, basically you have to create m plus 1 boxes like this. M plus 1 boxes. In each box there will be some zeros. But now your task is to make sure that all of them have the same length. Why? If they have the same length, like I showed you in the case of two boxes, when the such a nice, lovely problem. When m was 1, you created two boxes. When was the best answer for two boxes? When both the boxes had same number. So if there are multiple boxes, then also we want same number, but sometimes it's not possible to generate same number in all the boxes. In that case, there should be two different values at max in all the boxes, and the difference between those two values should be 1. That is the best possible answer you can reach. For example, if 3 comma 3 was not possible, then 2 comma 4 or 4 comma 2 would be the answer. Same way here, in each box there should be a y, and if that y is not possible, then in some of the boxes there should be y, and in the other boxes you will put y plus 1. Now you will say, sir, from where this plus 1 is coming? This is the remainder getting left out. So this is the best distribution because all the boxes have either y in them or they have y plus 1 in them, which is not a big difference. It generates same effect as y. Okay, so hopefully you got this clear, and you will get the code for also for this, so you will be easily be able to generate the string. And now to calculate the total final answer is also very easy. You know f of s, right? Total. And g also you can calculate easily if you know how many boxes have y in them and how many boxes have y plus 1 in them. You can calculate that easy. If you calculate the remainder, let's say remainder is 3, it means in 3 boxes you have to add 1 extra 0. So 3 boxes will have y plus 1. The remaining boxes of total will have y. So here you will do what? Y into y plus 1 by 2 multiplied by some number, which is this number of boxes. And here y plus 1 into y plus 2 by 2 depending into remainder number of boxes. So this is easy. Now guys, let's go to the final thing, which is prove it. let's mathematically prove why always dividing in the middle is best in m equal to 1 case, and because it's working in m equal to 1, it's working for a bigger m also. So here, this is the length, right? Let's say for n equal to 7, m equal to 1, you know that you will put 1 somewhere, so the leftover length will be what, of 6, right? So let's say for l equal to 6, which are the ways to divide? 6 comma 0, 5 comma 1, like this, but the best one is equal case, and 0 comma 6 till then, right? So if this is your length l and you divide it in the middle, this part will be what? L by 2. Let's assume L is even. You can prove for odd also. This is L by 2. So what will be the final value of G? Minimum G will be L by 2, this case L by 2 into L by 2 plus 1 by 2 plus L by 2 into this case L by 2 plus 1 by 2. This is nothing but what? L square by 4 plus L by 2. Now let's say you change the configuration. For the middle one, for the middle one, if you break this L, if you break this L in the middle, this part having zeros is L by 2, this part having zeros is L by 2. And this middle one we are not considering because n was 7, then only L becomes 6, right? So in this case, the minimum G is coming by formula as L square by 4 plus L by 2. But what if you change the configuration? What if you break this at a non-middle length? Let's say the left part is now L by 2 plus 1 and the right part is now L by 2 minus 1. Basically, you shifted one step ahead. Earlier you were breaking in the middle, now you are breaking one step ahead. Left part is L by 2 plus 1 and right part is L by 2 minus 1. So the answer will be L by 2 plus 1 into L by 2 plus 2 by 2 plus L by 2 minus 1 multiplied by L by 2 by 2. This is nothing but, if you calculate it, it's L square by 4 plus L by 2 plus 1, which is bigger than this. So guys, mathematically, you can see that the minimum G, even if you shift one step from the middle, the minimum G value is bigger. This value is bigger. L square by 4 plus L by 2 plus 1 is bigger than L square by 4 plus L by 2. So the middle way is the best way. So that's why, let's say you do a one shifting. So what will happen? This is L by 2, right? This 3 is L by 2. For L equal to 6, this 3 is L by 2, this 3 is L by 2. But if you do one shifting, what is the shifting? L by 2 plus 1. So 4 is in the left part and L by 2 minus 1. So 2 is in the right part. What is the answer if there is 4 and 2? The answer is bigger. It is 4 into 4 plus 1 by 2 plus 2 into 2 plus 1 by 2, which is 4 into 5 by 2, 10. And here it will be 3. So 13 is coming. But if in the equal manner, one, see, in if you shift by 1, the answer is plus 1 extra, but in this there is no plus 1. So in this one, 12 is coming. 12 is the minimum value. So guys, hopefully you enjoyed this problem and loved it. The C++, Java, Python solutions I will show you, and then we will close this session. Ram Ram. The new year is coming. Hope you guys are having fun and you love enjoying this DSA problem. So now, the C++ problem, guys, here it is. You can check the code. It's very, very easy. You solved a ATLPS CTC problem. Yeah. You can see NM, NM, things are done. Solved. Similarly, guys, in Java, I hope you get the best job you can get. You raise the economy and GDP of the country. I hope you fall in love with the technical aspect and you don't have any kind of overthinking and stress in life. I hope you the best life for the new year and even today and tomorrow. Okay. So, Ram Ram, guys. Ram Ram, Ram Ram, Ram Ram.